So as I mentioned before, we've been in dozens of offices. We have a lot of friends in the industry that are technicians. And interestingly enough, one of my friends sent me this photo of an air water syringe. Now what you can see on that napkin is what we call bioworms or biosludge. So the story behind this is he was called in to fix the air water syringe. The water was not coming through. And a trick of the trade that he does is he switches the water and the air in the air water syringe and actually blows that air through the water line. And as you can see, we have bioworms on the patient napkin. Unfortunately, this office was treating patients throughout the day, and so this is becoming a huge problem in the dental field. We're seeing time and time again that water lines are being clogged, they're not being taken care of. We see high numbers of bacteria coming back on our test, and this biosludge is getting into patients' mouth during their procedures. Whether that's a routine checkup or an extraction, we're finding that these failures are becoming more and more common throughout the dental field. So let's talk about biofilm. Biofilm is the main problem that we have. Now, why is biofilm such a big problem? Well, as it grows in the dental unit water lines, it actually sticks to the lines themselves and start building up. Underneath biofilm, there's called a biomatrix, and it's something that is a grid-like pattern that biofilm or bacteria like to stick to. So as biofilm is growing, it is made up of a bunch of different bacteria that as water is running over that built up biofilm, it will break off. And those little pieces of bacteria now are headed towards the mouth of the patient. So as that bacteria breaks off and heads towards the patient's mouth, it can cause major problems because the mouth is the gateway between the heart and the brain. So we want to ensure that there's no bacteria in the water lines in general. Now, why is it such a big problem with aerosol bacteria? We have the high-speed handpiece, and you can see the water that's misting off of it. As that is entering the patient's mouth, it's releasing the aerosol bacteria because there's pressure. It's hitting the patient's mouth, their bacteria is now in the air, the bacteria that is in the dental unit water lines are in the air, and we're breathing that in. So specifically, the air water syringe has a positive pressure, and anytime that we have positive pressure, we have negative pressure. So as that water is going into the patient's mouth, it's causing aerosol bacteria coming out of the mouth of the patient. Now, the moment that we release off of that positive pressure, it pulls in the aerosol bacteria. So that's why it's so important that we're flushing those lines in between the patients. This is a great example of why the dental office is such a big problem for aerosol bacteria, and the dental unit water lines have to have something that is correcting the problem of bacteria in the lines. A lot of people tell us, well, I use distilled water, so I'm starting at 0 CFUs in my bottle. But just with that example of the air water syringe, we don't have an active ingredient that's fighting the risk of the bacteria coming back in with that negative pressure. So again, that's why it's so important that on both ends we have that active ingredient fighting the biofilm and the bacteria that we're introducing into these dental unit water lines. Now, why specifically dental unit water lines? Why are they such a big target for biofilm buildup? Well, as you can see in this graphic, the water lines are very small and there's a lot of tubing running through the dental unit water lines. You have a 10 millimeter water line running specifically through this unit. Now that causes a lot of surface area that the biofilm is able to latch onto, especially if these are older lines. We have built up biomatrix. Again, that's the grid-like pattern that has been laid onto the water lines. So as that fresh bacteria is flowing through these lines with a lot of surface area, it's something that it can hold on to. And then as that water sits over the weekend, it has a warm environment for it to grow. You also can see this in cavitrons. Anything that has water and a water line, you have a great amount of surface area that it can be attached to. These units are normally not used during the weekend, so they sit idle, and in those warm environments, they keep continuing to grow. You can see numbers exponentially grow just over one weekend. If they have nutrition and they have warmth and places to grow, you'll see bacteria counts get out of hand.